Hi, I'm going to be solving a differential equation by the method of separation of variables. A separable differential equation is in the form n of y dy over dx equals m of x. Therefore, you can take a function of y dy on one side of the equation and set it equal to a function of x dx on the other side of the equation. Then, if you integrate the left side with respect to y and the right side with respect to x, you arrive at the general solution to the differential equation. The differential equation that I'm going to be solving is dy over dx equals y squared minus 1 over x squared minus 1, with the initial value y of 6 equals 6. To begin, we want to find a function of y times dy on one side of the equation and a function of x times dx on the other side of the equation. This can be achieved by taking the reciprocal of y squared minus 1, 1 over y squared minus 1, and multiplying it by dy on the left, and setting it equal to 1 over x squared minus 1 multiplied by dx on the right. We can now integrate each side of the equation to find our general solution. To find the integral of 1 over y squared minus 1, we use the method of partial fraction decomposition. To begin, we factor the denominator to give us the integral of 1 over y minus 1 times y plus 1. We can now rewrite this as partial fractions to give us the integral a over the first factor plus b over the second factor. Next, we want to solve for values of a and b. This can be achieved using the common denominator. If we multiply a times y plus 1, and we multiply b times y minus 1, then we have a common denominator for the two fractions. Taking this equation and setting it equal to the constant, we can now solve for a and b. To solve for a and b, we want to plug in values of y so that one of the variables equals 0. First, we plug in y equals 1. This gives us 1 equals a times 1 plus 1 plus b times 1 minus 1. Now our b equals 0, and we have 1 equals 2a. Therefore, a equals 1/2. Next, we plug in y equals minus 1. This gives us 1 equals a times minus 1 plus 1 plus b times minus 1 minus 1. This gives us a equal to 0 and 1 equal to minus 2b. We can now solve for b to give us b equals minus 1/2. Now we can plug in values for a and b into our integrals to solve. This gives us the integral of 1/2 over y minus 1 plus negative 1/2 over y plus 1. This integral can be rewritten by the principle of linearity to give us two separate integrals. 1/2 the integral of 1 over y minus 1 minus 1/2 the integral of 1 over y plus 1. We can now solve our integrals by the method of u substitution. If we set u equal to y minus 1 and du equals 1 for the first integral, and u equals y plus 1 and du equals 1 for the second integral, we can rewrite the problem as 1/2 the integral 1 over u du minus 1/2 the integral of 1 over u du. We can now solve these integrals to give us 1/2 ln u minus 1/2 ln u plus c. Now our solution can be rewritten by the principles of logarithms to give us 1/2 ln y minus 1 over y plus 1, plugging in the values for u, y minus 1 for the first logarithm and y minus 2 for the second logarithm, to give us our solution of 1/2 ln y minus 1 over y plus 1. We now have our solution to the first integral, 1 over y squared minus 1. Because the second integral, 1 over x squared minus 1, is identical to the first, we can use our same solution, plugging in values for x, to give us the general solution to our differential equation, which is 1/2 ln y minus 1 over y plus 1 equals 1/2 ln x minus 1 over x plus 1 plus c. We only need to include c on one side of the equation, because if we take c2 minus c1, then we result in a single value for c. We can now simplify our general solution using the principles of logarithms. First, we cancel 1/2 from each side. Then we have ln y minus 1 over y plus 1 equals ln x minus 1 over x plus 1 plus c. If we take e to both sides, then e to the ln cancels, and we have y minus 1 over y plus 1 equals x minus 1 over x plus 1 plus c. This is the general solution to our differential equation. We can now plug in the initial value to solve for c. If we plug in y equals 6 and x equals 6, we have 6 minus 1 over 6 plus 1 equals 6 minus 1 over 6 plus 1 plus c. Now if we subtract 6 minus 1 over 6 plus 1 from the left side, we have c equals 0. We can now plug in our value for c into the general solution to the differential equation to give us y minus 1 over y plus 1 equals x minus 1 over x plus 1. And this is our general solution. Now we want to express the general solution as a function of y, so we have to solve for y. We can use fraction cross multiplication to give us y minus 1 times x plus 1 equals x minus 1 times y plus 1. Then if we expand and simplify, our result is y equals x. This is the final solution to our differential equation. Thank you.